Okay, good afternoon, everyone. Today we're going to continue our discussion on multiple linear regression. By way of review, what we're using here is the wage dataset that I provided you with. So that dataset should be in your, okay, sorry about this, should be part of your files. Okay, and we have learned many times how to load your dataset to R. Okay, so this is our dataset. And then we already did the preliminary steps. We said that the first model that we created is a simple linear regression. Hourly wage regressed on education. The reason why we're using education as the first simple linear regression predictor is because education has the highest correlation with hourly wage. So we did this before, okay? All right, and then let me introduce to you some functions which we have learned in the past. So kindly load there's a package called performance. Okay, Control Alt I. So install that packages. Okay, and then tap small p performance. Okay, and then of course let's require that. Let's load that. Okay, so I'll give you a few a few seconds, class. Once you're done, kindly chat, please, that you have loaded the performance dataset. I'm not dataset, I mean the package. Kindly PM class, yes, if you have loaded. Okay, thank you. Okay. All right. So let's first take a look at what this function does. Okay. So maybe we can let's see the citation. I forgot to tell you about this. The citation function. Okay. If we cite this citation, if you want, for example, to cite this in your, oops, what happened? Sorry. You have to have quotes here. Citation of performance. Let's see. The authors, okay, if you want to cite in your research the package that you're using, you can use this to cite package performance. So this was written by Ludeke, okay, an R package for assessment, comparison, and testing of statistical models. So this was contributed to the Journal of Open Source Software. Okay, so this is the link, okay, of this journal, 2021. So medyo bago lang to, no? Itong package na to. And let's see here. So you should have already loaded this in your packages. So performance. Okay, andito naka-check na dapat siya, no? Assessment of regression models. Okay, click natin. Okay, so these are some of the functions. Check autocorrelation, check collinearity, check let's see, distribution, check heteroscedasticity. Okay, so which means, class, that you can later on, I'm going to show you that you can use this to evaluate the. Remember that after you create your linear model, that it's not enough for you to just come up with the equation. You will have to check the validity of your model by checking for if it if there are any violations of the assumptions. So you can see here, there are many things that we can check normality, check outliers. Okay, so many functionalities here. And I leave you class to to explore for yourself. And maybe we can look at this description file. So this is performance package assessment of regression models performance. The version now is 0.10.9. Okay, the author is Ludeke, as I mentioned a while ago. And may iba pa siyang, siya yung pinaka-creator si Ludeke, no? And then may contributor, author din si Makowski, si Ben Shar, Patil. Okay, there are other contributors to this. Okay, and of course, if you want to see the documentation of this, we can either go, asan na yung PDF nito? Okay, so German si Ludeke, Deutsch DE, that's Deutschland. Okay, saan ba yung ano? Sa CRAN. Anyway, class, hanapin nyo lang sa CRAN yung ano, no, yung documentation nito. Sige, tingnan na lang natin, no? While we're here. Performance package. Okay. So I'm looking for the CRAN, labang CRAN. Ito to. CRAN, no? Assessment of regression models performance. And then you can get here the PDF. Always pays class to, asan na yung PDF nito? Where's the PDF? Bug reports. URL. Nasa GitHub, eh, no? Okay, anyway. So, ito lang. Ito pala, reference manual. There. Performance.pdf. Always a good practice class to study the package. Sabi niyo, oops, mabalik sa ano? Adobe. Wait. Oh. Anyway, I'm having problem, no? Okay, so I leave that to you, class, to look at that. Okay. All right. So let's just have a check class. Let's see. What does the performance package do? Pwede natin tingnan yung model number 1. Of course, this is not yet our final model. Simple regression lang to. But just to show you, class, what this does. So it gives us some metrics, no? Model performance na model 1, it gives us the Akaike information criterion, and then the AIC corrected, and then BIC, R squared adjusted, Ramsey, root mean square error, and sigma. Okay, so this is SE ba to? Standard error ba to? Okay, I think this is standard error of the of the slope, no? If I'm not mistaken. All right, so it just gives us some summary statistics, not statistics, but summary metrics for model number 1. Then we did model number 2 class, and we said that this time we're going to make use of everything, all our variables. So this is just a quick review with the summary. This is what we did last time. And we noticed that there were insignificant variables, insignificant predictors like race, civil status, number of dependents. And what we did last time was to look at the anatomy of this output and determine which of these were significant predictors of hourly wage and at what level of significance. Yung mga 3 stars lang dito, which are significant at the 0.1% level of significance, are the only ones that are statistically significant. So we also studied the meaning of this class, yung default na dummy variables. Itong 1.76 means that on the average, male employees tend to receive $1.76 more than their female counterparts, ceteris paribus, and this is statistically significant. And we said that the significance can also be looked at in from the t-value. I think the t-value that we computed using the qt function, degrees of freedom is 518, no? Okay, 518. Degree of freedom 1 is 7. Degree of freedom 2 is 518. That's for the f-stat. For the t-stat, for the t-critical, it's 1.96, I think, no? Okay, sige, gawin na lang natin para sure. Okay, quick review lang, class. So, QT, okay, this is to compute for your for your critical value. Okay, so what's our P here, class? What did we learn last time? Okay, so gamitin natin alpha is 0.05, and then degree of freedom is what's n row n minus, okay, I'll just write here predictors is 7, but we can create a formula for that minus 1. Okay, so our QT class is, this is just a quick review class. What should it be? So we're looking at it from the right side, since this is two-tailed. So ang ano natin, ang P natin is 1 minus alpha divided by 2. And then our degree of freedom is df. So if we run everything here, okay, so it's 1.96. So that's our T critical, and we said that any T value that's greater than 1.96 will be in the rejection region, which means that the variable is statistically significant. Okay. Okay, any questions, class, so far? Paki-chat nga kung clear. I'm going through this very fast because we have already discussed this. And I don't want to keep on repeating what we have discussed in the past. Okay, thank you. All right, good. Thank you. How about the others? Okay, so we can look at whether the parameter is statistically significant via the p-value or the t-value. Sa p-value naman, if it's less than 0.05, then it should be statistically significant. These 3 stars indicate that it's significant at 0.1% because the p-value is less than 0.1%. Okay, so we said that if we're going to stop here, only the education, tenure, and gender will enter the picture. But we said that we don't drop everything. Okay, what we do now is to conduct what we call stepwise regression. And we said that in stepwise regression, in particular, this is backward stepwise regression, because what we're doing is we're loading all the predictors first and then remove one by one. That's why it's backward. So the lowest t-value is race. Okay. So that means that this is the leading variable. So we'll now create a new model where, okay, model number 2. Here. Wala yung model number 2. Ito pala, sorry. It's here. Okay. So model number 2, hourly wage regress on everything. And this is the result. Okay. I'm sorry, class. Yeah, this is already model number 2. Okay. And then the leaving variable is raise. So we now go to model number 3. Okay. All right. By the way, we can also use the compare performance. Okay. So aside from ANOVA, we said that one way to compare between model 1 and model number 2. Model 1 being the restricted model because it has only one predictor. Model number 2 is the unrestricted. Model number 1 has only education. Model number 2 has education plus the others. So ANOVA we know already, but compare performance class, model 1 and model 2, and then rank is equal to T. If you run this, okay, it will generate this one. So hindi lang masyadong clear class yung table, no? So these are the parameters: name, model, R squared adjusted. Ramsey is root mean square error. Sigma, AIC weights, AIC corrected weights, and then BIC, and then performance score. So it's quite challenge to read this. So first, yung model ni model number 2, pareho silang LM. Tapos ang R squared ni model number 2, 0.37 as compared to 0.16, around 16% for model number 1. In terms of adjusted R squared, mas maganda class si model number 2. Okay, root mean square error. So this is a measure of the error class. So the lower, of course, the better. Model number 2 is better. And that's to be expected kasi mas maraming predictors siya. No? So pag mas maraming predictors, mas nami-minimize yung residuals, yung error term. Okay? And then, we'll not discuss now yung AIC weights at saka AICC weights. Ito lang yung performance score class. So it assigns a percentage to the performance of each model. Ang sum niyan dapat 100%. So since dadalawa lang siya, si model number 2 ang 100%. In terms of performance, mas maganda siya kay model number 1. Okay, so that's one way of looking at the performance, comparing model 1 and model number 2, which is the same as yung ANOVA naman natin class, statistical test on. Okay, so the null hypothesis here is that the restricted model, which is model number 1 here, is the better model. And based on the p-value, which is practically 0, so this is 3 stars, which means this is significant at the 0.1% level. Our conclusion is we reject the null hypothesis that education, model number 1, the parsimonious or the what's that? I forgot the term. Anyway, the parsimonious model or the limited model is the better model. We reject that. Okay, the restricted, I mean, sorry, I was grasping for that term. This is the restricted model, and because of the p-value, which is less than 0.05, we reject this proposition. So the model number 2, which consists of the 7 predictors, is better than model number 1. Okay, then we can now just kindly copy this. Okay, we can plot the difference between we can do this plot function and compare performance. Okay, and then model 1, model 2, and then rank is equal to true. Okay, and then we run this. You can see here a curious plot, no? It's a curious plot. So this one tells us the comparison between model 1 and model 2. So it's like a spider web plot. So in this case, what's being measured here is the higher the value, even for AIC weight, the better. So iba yung ano nito class, iba yung reading nito ha. Kasi we know that in terms of value, the lower the AIC, the better. But that's not the way to read this, itong plot na to. Pag mas above yung line niya, for example, this is model number 2. So in terms of R squared, mas okay siya model number 2 compared to model number 1. In terms of adjusted R squared, mas okay din siya. RAPSI also, sigma, AIC, uh, AIC weighted, BIC weighted, and then the R squared. In all aspects, mas maganda si model number 1. Okay? So that's what this plot compare performance does. Okay, let me pause for a while. Are there any questions? Kanina ginawa natin yung compare performance. No? Kaso tabular siya. Dito, pinagawa natin na plot. Okay. Kindly chat, please, if we're clear so far. Actually, this can be part of your diagnostics, no? When you're comparing the models. Okay, compare performance, and then if you attach plot to it, it will give you this diagram. Okay, so will not. I'll delete this. Will not. I'll put this here. The model number 1 too. Okay, let's check now model number 2. Let's not check model number 1. Here. Check model 2. Okay, so you may wish to copy that, run that, and run it, what we get. Okay, so it will give us some plots. This is just like the, if you recall class, okay. Diba may plot function si mod 2? Mod being an LM function. Okay, naalala nyo to? Diba? Actually, 6 plots siya, no? Pwede natin isa-isahin, di ba? If you recall, which is equal to 1, which is equal to 2, etc. Now, this is quite similar to the check model function. Tignan nyo. Check model. Yeah. So, what's good about this class is, as compared to the plot function, is that it gives us some guidelines. For example, let me. Okay. So take a look at this. Posterior predictive check. So it tells us that the model predicted line should resemble observed data line. So this checks for linearity. Okay, ito yung ano dito, yung green class, yung green, ito yung predicted ano natin. Tapos yung, sorry, yung green is your observed data. This is your actual data. And then the model predicted is the blue one. So dapat, sabi niya, as much as possible, the observed value should be, of course, quite similar to the predicted value. Ito yung predicted value, yung kulay blue. Ito yung observed value, yung green. All right, then for the others, for example, ito linearity, reference line should be flat and horizontal. You can see here, this is a plot of your fitted values and your residuals. And you can see here, the plot does not seem to, to a certain degree, dito sa portion na to, no? Yung reference line should be, ito yung reference line natin eh. So at the onset, hindi siya flat, no? Dito, mas nagiging flat siya. Pero pagdating dito sa higher values ng fitted values, hindi na naman siya flat. Okay, this is already partial of your of your diagnostics. Of course, when you generate this, hindi pa pwedeng flat lang. You will have to analyze. Okay, and then this one is a measure of heteroscedasticity. Reference line should be flat and horizontal. What's being measured here? Fitted values versus the square root of the standardized residuals. So sabi daw, dapat yung plot na to, as much as possible, flat lang. But you can see here a problem with respect to, okay, homogeneity of variance or constant variance. Okay, influential observations, dito class makikita natin dito, the point should be inside the contour lines. So these are your contour lines. And although these numbers here pertain to the outliers, okay, but yet they're not outside the contour lines, which means that they are not really they're not influential observations. If you recall, class, what's the meaning of influential observations? It means that class, these points could highly affect the parameters, the regression output, kung outside sila. And then this one also is a measure of okay, this one is VIF plus variance inflation factor, and then this one is this one is the normality of the residuals, so that should fall along the line. But you can see here yung mga higher values plus medyo malayo sila dun sa dun sa line natin. All right, so that's just a quick a quick analysis class. And then we said that our model should not stop there because we will have to remove the lowest t value, it's raised. So in the next model, model number 3, what we did was to remove yung raise. So dito sa model number 3, wala nang raise. Stepwise regression tayo dito. And then if we run this, okay, so we can compare performance. No? We can compare performance ito. Model performance muna. I will not do that anymore. Okay, and then compare performance. Model number 3, it's on model number 2. And you can see here the spider. Hindi pala, sorry. Flat dapat. Sorry, nakalimutan ko yung flat. Madali ko siyang mabasa dun sa flat. Control C. Then let me put flat here. Flat. Parang spider flat ang lalabas. Okay, so you can see here, this is the comparison of model number 3 and model number 2. Okay, you can see here that in some of the points, mas mataas si blue, no? So there are points here where model number 2 outperforms model number 3. In terms of BIC, AIC, sigma, mas maganda si model number 3. In terms of Ramsey, also R squared, mas maganda si model number 3, but in terms of R squared, mas maganda si model number 2. So graphically, makikita nyo class which of the model is better. No? Okay, but of course, we said that we have a model number 3 na tayo, no? Meron tayong ANOVA, no? So physically test, model number 3, model number 4, and the, model number 2, Model number 3. Okay, the restricted model here, class, is model number 3. Kasi binawasan natin si model number 3. The unrestricted is model number 2. So if we run this, what will happen is that yung table na to, class, yung model number 1 is your may raised to, no? So this is your unrestricted dito, unrestricted yung model number 2. Okay, and then the null hypothesis is that the restricted model is the better model. Okay, so since the p-value is 0.8, if we reject the null hypothesis that the restricted model is better. Diba? Diba? Okay, ulitin ko baka nalito kayo. No? Ilan bang predictors to? 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6. Tinanggal yung raise. Diba? So we're saying here that either the unrestricted class, ito, no? Yung walang raise. Ito yung unrestricted. So ang answer, class, the p-value is 0.79. It's way greater than 0.05. So we fail to reject the null hypothesis that the restricted model is the better model. Okay, so mas maganda yung restricted, yung tinanggalan ng gender by virtue of this F stat and the probability. Okay, so, and then of course, model number 3, ano? Then, again, doing the same thing, tatanggalin natin si number of dependents because this has the lowest absolute value of your T stat. So, tanggal si number of dependents, 1, 2, 3, 4, 5 na lang ngayon, no? 5 na lang yung predictors natin. If we run this, so, linagay ko na yung summary dito, no? Para isang run na lang. Summary and then model number 4. Okay, so how to evaluate this class? Okay, this one we know, class, no? We know experience is not significant here. Civil status is also not significant. 5%. So pwede natin, kung compare natin, class, okay, okay na lang natin. Control C. I-plot natin, class, yung this one will be now model number 4. Model number 4. Okay, run this. So, medyo ano na, no? Medyo parang lumiit yung certainty na mas maganda si model number 4, yung restricted model. Kasi si model number 4 is beaten already in terms of R squared, adjusted R squared, Ramsey, and sigma. So medyo panalo lang siya dun sa ano sa BIC, AIC, at saka AIC corrected. Based on this, no? Based on a comparison of the model. All right. Pinaplot lang naman niya, class, yung actually easy. And the last one is lowest T value is experience. So 1, 2, 3, 4. Apat na lang na predictors. So let's run this. Now you can see, class, that all the variables are significant. Okay, all the variables are significant, di ba? So this tells us na wala na tayong living variable dito. Wala na tayong ma ah, matatanggal na variable. So let's just check, class, model performance natin for model 5. You can see here the measures. And then i-check model natin, model number 5. Okay, yung plot to, no? Yung mga plots. Okay. So here, makikita natin yung kung yung ano natin yung predictor natin is it close ba siya sa ano? So this is also a measure of not only linearity but also yung residuals ng homoscedasticity. No? So dito, okay, although may mga ano tayo dito, no, may mga may malaki yung variances dito. All right. Okay, normality of residuals, medyo may problema tayo ng konti doon. No? Okay, so lastly, i-plot na lang natin, same as a while ago, plot natin, kasi hindi maganda kung compare performance lang kasi hindi masyadong kita yung ano, mahirap mabasa. Kung naka-plot, at least kitang-kita natin. Okay? So dito sa model number 5, you can now see that parang in terms of R squared or adjusted R squared, mas maganda si model number 4. Okay? So using this metrics, ang pinakapanalo lang ni model number 5 is Bayesian information criterion lang. The rest, better si model number 4. No? But this one, class, please take note that this one do not consider yung significance. Okay? Kasi ito mga metrics lang to na ano eh, hindi to nagche-check hindi to inferential. That's what my point is. Kaya nga, we need to do this ANOVA. No? Okay? So ANOVA kasi in terms of the compare performance ni performance package, mas maganda tong mga just basing it on ano ba yung measure ng R squared, adjusted R squared, yung root mean square error, sigma, etc. It turns out that parang mas maganda si model number 4, yung unrestricted, no? yung merong number of dependents kasi yun ang huling tinanggal natin di ba? That was the last variable that what was that? Experience pala, sorry. Experience. Okay. So where am I? Okay, so ANOVA, class, ANOVA. Okay, again, what's a null hypothesis here? Yung model 1 dito, class, yung walang number of dependents, no? Walang experience. So this is your restricted model, si model number 1. Si model number 2 is your unrestricted. Okay? And the null hypothesis that model number 1, the restricted, is better than the model number 2, which is your unrestricted. AKA, class, in other words, we're saying that hindi naman kailangan we don't need to put experience as a predictor. Okay? That's saying that the restricted model is better. Yung walang experience ito. So the p-stat is at 0.1198, no? 0.1198. Okay, so kung 0.1198 siya, class, p-value is greater than 0.05, so we fail to reject the null hypothesis that the restricted model, which is this one, is the better model. So we fail to reject that. No? So ibig sabihin, model number 1 is the quote-unquote better model, yung walang experience, yung tinanggal natin yung experience. Okay, pause muna ako, class. Any questions about that? So that's model number 5. Okay, yan ang pinaka final model as far as our data is concerned. Okay, lahat ng predictors, lahat significant na. Okay, any questions? Okay, chat nga please kung clear tayo so far. So I hope all of you got up to model number 5. That's the final model. Okay, so how do we now write? Thank you. Thank you for your feedback. How do we now write, class, our model, our final model? Anyone? How do we write our final model? My 10. Okay. Sorry, class, hindi ko makita yung digital pen ko. Okay, anyway. All right, so our final equation will be, okay, our hourly wage is equal to negative 2.16. I'll just round it off to 2 decimal places, plus 0.553 times education, plus 0.15 times tenure, plus 1.7 times gender, okay? And then minus 0.68 times civil status, plus your error term. So it's very important for us to understand what this means. So for education, class, it means that for every 1 year increase in education, there's a corresponding $0.53 increase in average increase in hourly wage. Okay, assuming that all the other parameters remain the same. Okay, kita ko na. So our equation is, let me write here, hourly wage sub I, we can put here a hat, is equal to negative 2.16 plus 0.52. I'll just round it off 53 to 2 decimal places times education, ejuk sub I, plus 0.15 times tenure sub I, plus 1.71 times gender minus 0.69 times civil status. Okay, I'm not going to put the plus error term because this is your predicted. Okay, so yan ang final model natin, class, and you notice that all the predictors are significant. Of course, yung intercept, okay, kahit na hindi siya significant, we do not initiate a step to remove the intercept, and we still include that in our model. All right, so any questions, class? Any questions? So far, clear ba tayo? Kindly chat, please, if we're clear. Okay, I think I saw a question. Glenn, my values on the intercept in model 5. What's the value of your intercept, Glenn? Glenn, are you referring to the final model?
Yes, sir, mod 5. But I already know why it's different, sir. It's because yung respect ko is female, not male.
Okay. Oh, yeah. Magkakaiba nga. So it depends on your reference reference point for your factor. Okay? So magkakaroon class ng ng difference. Okay, one last question, class. What's the meaning of negative 2.16? What's the meaning of negative 2.16, class? Negative intercept. How do you interpret this? How do you interpret this? Okay, we discussed this last time, di ba? So negative 2.16, class. This is the intercept. So this is the average hourly wage of a person who has, by definition, yung intercept natin, lahat ng mga parameters equal to 0. No? So who has no education, no years of tenure, who is what? Who is, dapat is-zero out natin to, no? Kasi 1.71 na yan, class, for male yan eh, in reference to the female. Okay, so dapat zero yung effect nitong nitong gender, at saka zero din yung effect nitong civil status. Okay? So, it means, class, that this is the hourly wage of a person who does not have education, no tenure, who is female, who is sino pa, class? Female siya, tapos sino? Married siya, tapos non-white, di ba? Female, married, and then non-white. Ba't sinali natin si non-white? Okay? Kasi, di ba, class, hindi siya significant. Ibig sabihin nun, zero effect yun. Yung zero na yan, class, that will refer to your non-white. So just like here, yung male, zero out natin to. Kasi itong 1.721 na to, okay, this is for the male. So ibig sabihin, class, if I want to know what is the average hourly wage for a person who has no education, no tenure, okay, who is male, who is single, okay, who is male and who is single. It doesn't matter kung non-white or white. What will be the answer, class? So that's negative 2.16, and then we will add this 1.17 kasi male siya. So idadagdag natin to. And then single siya, so dapat negative 0.60, around 69. Okay? So if I perform this negative 2.16 plus 1.17 plus negative 0.69, okay, that stands for the average hourly wage of a person who has no education, no tenure, who is female, okay? Okay, sorry. So, who is male? Kaya nga dinagdag natin to di ba? Who is single, okay? And it doesn't matter kung white or non-white siya. Kasi hindi naman significant yung white at saka non-white, yung race. Okay? So we'll deal more with that as we go along. Kasi ano tayo na interaction variables, and that's where that will come from. Okay, any questions, class? Okay, may question yata dito si question ba to, Abigail? Abigail, question ba to, or you were answering? Okay, I think you were answering, no? And it's correct, no? It's correct. But then again, class, yung i-share niyo answer niyo sa ano to everyone. Okay. So now, exit muna ako. Let's now go to a quick way to do your stepwise. Kasi paano class kung paano kung marami kayong predictors? Di ba ang tagal-tagal nun isa-isa natin. Okay, so let's now go to, bago tayo mag-diagnostics, punta na tayo class sa isang package called ito, OLSRR. So let me just share with you some of them sa chat box. Okay. So sabi natin class, we know that stepwise regression, we pag pag if it's forward, we introduce the variables one at a time. The variable that will best improve the model is chosen. Tapos siya yung i-insert natin. On the other hand, pag backward, you load all the variables, and then isa-isa tatanggalin natin. Okay. So this one, class, let's first create this model. Ano lang, class, please insert a code chunk. Okay. We're creating this model 1, 0, which is actually our model 1. We're regressing hourly wage on all the predictors. Okay. And then tell me, don't run this first. Pwede nyo copyhin, pero i-run muna natin to and tell me, class. Of course, you'll be getting ito yung similar to model number 2, no? Because we're regressing hourly wage on all the variables. So if I run this, so ang model number 10 natin, ano ko lang, i-summary ko, no? Summary, mod 10. Okay, and you can see it's hourly wage regressed on all of our predictors. Yan. So ito yung model number natin, model number 2. And then, by the way, baka hindi nyo pa na-load. Dati na-install na natin si OLSRR, no? So just make sure that you have OLSRR. So this is tools for teaching and learning OLS regression. There. So make sure it's loaded. Okay, attaching package OLSRR. Okay, then kindly copy this class, OLS step both P. And let's see what that means, class. What does this generate? If we run this, ordinary least squares step both, no? Stepwise, kasi my forward, my backward, ito both, no? So there is a stepwise regression that combines yung forward at saka backward. And then dash P means that the the basis for introducing a variable is that its p-value should be less than 0.05. Kasi may isa pang method. But let's first run this. Control Enter. All right, and then you have here the summary model. Okay, so let's see what this means. No? Okay, number one, ang unang pinasok class is education. All right, and then it tells here kung inad ba to o sinabtract. Inad daw. Then it gives us a measure of if education is our predictor, how much will be our R squared, adjusted R squared, our Mallows CP. Okay, discuss natin more later yung ito Mallows CP yan, kung ano ba ibig sabihin yan. Okay, Mallows. Okay, and then we have others here. Okay, so quickly class, AIC and then Ramsey. So variable, added, R squared, adjusted R squared, Mallows CP, AIC, and then Ramsey, root mean square error. So for the first step, ang pinasok niya muna education, inad niya, no? And ang naging R squared is 0.165, and then adjusted R squared, and then Mallows CP is 165.20, AIC is 297.77, and the Ramsey is 3.37, 3.38. And then next, pinasok si tenure. So ito class, although ang nakalagay dito both, no? Ito ang nakalagay dito both ways. Okay, it started with a forward. Pinasok niya muna sa education, tapos pinasok si tenure, no? Nung pinasok si tenure, ano nangyari? Nag-improve yung R squared, adjusted R squared. Okay, nag-improve yung CP class. Okay, this is yung Mallows CP, the lower the better. Okay. Okay, then number 3, pinasok si gender, addition pa rin. And then notice na tumaas si adjusted R squared, tumaas si adjusted R squared, at si R squared. Bumaba si Mallows CP. If you're going to compare all these three models, in terms of R squared, mas maganda si model number 3. In terms of adjusted, mas maganda pa rin si model number 3. And in terms of Mallows CP, mas maganda pa rin si model number 3, which includes gender. And lastly, class, pinasok si civil status. Ano nangyari? R squared, umangat. Okay, adjusted R squared, umangat. Mallows CP, bumaba. Ramsey, kaya nangyari kay Ramsey, bumaba din. Tapos si ano pala yan, AIC, no? AIC, tapos si Ramsey, bumaba. Okay, so that's the result of this function, OLS underscore step underscore both underscore P. So this is based on the P value. Papasok lang yung variable kung, okay, kung ang P value niya is less than 0.05. All right. Then we go here, class. I-plot natin to. So let's create this object called K, and then we're assigning the object K to this object, or let's step both P yung ginawa natin kanina, and then let's plot K. Okay. Do you get, class? All right, plot natin. Okay, so you can see here, Plot natin dito class. First one. Okay. So dito, adjusted R squared at saka adjusted R squared. You can notice that if you only introduce one variable, ito na adjusted R squared natin. Pag nag-introduce natin yung second, tumaas, tapos tumaas, tapos tumaas. Okay? So, dun sa four variables natin, ito yung medyo nasa maximum siya, no? Yung pinakamataas na. R squared at adjusted R squared. And then, yung AIC niya, bumababa. Diba? O consistent po dun sa, sabi natin, if you have more information, more predictors, potentially bababa yung AIC. But there will come a point, class, na if you keep on adding more predictors, it will not necessarily result into a lower AIC. Tapos itong CP din, class, which is, as I said, class, itong malo CP na to, the lower, class, the better. Okay. And then this one, SBIC then, and SBC, okay, the lower the better. Alright, so ito yung plot natin, class, nitong ano, itong OLS step both. And pinat natin sige. Alright, any questions so far? May questions ba, class? Paki-chat naman please kung clear tayo. Okay, waiting for the others to give their feedback. Okay, good. Okay, let's continue, class. All right. So I'll share with you these notes na lang. All right, so some notes here. We're going to build a regression model from a set of candidate predictor variables by removing variables based on the AIC in a stepwise manner until there is no variable left to remove. Okay, so take a look at this. So ito, backward regression to, no? Kasi ipapasok muna natin mga variables, tapos iisa-isahin natin based on, take note of this, OLS step backward, yung kanina both, di ba? Then underscore P yung kanina, ito naman based on AIC. So which means that ang magiging decision class is magtatanggal siya ng variable class kung pagtanggal niya, bababa yung AIC. Okay, it will make its decision based on AIC. Sige, so let's create this object called K, and we're using this function OLS step backward underscore AIC, and then yung model 10 kanina, yung we're regressing all the variables. Okay, and then let's print this. Okay, okay, tingnan nyo, no? So ang basis dito class is AIC, ah. Okay, first class, so backward elimination to, di ba? First is full model, so kasama lahat. AIC natin is 2640. Okay, and then, yung unang leading variable is race. Ang AIC natin naging 2638. So bumaba yung AIC. So okay, tuloy pa, no? Tuloy pa. Kasi bumaba yung AIC. Tapos next, ang susunod na tatanggalin, number of dependents, no? So what happened? AIC also went down. All right. Now, it stopped here. Ibig sabihin dito, class, na our final model is the one without race and number of dependents. Okay, ito yung final model natin. Okay, any questions? Yung tinanggal natin yung race at saka number of dependents, yung 5 na lang natitira, based on AIC class, based on AIC, yun ang final model natin. So, ano yung mga predictors natin? si education, okay? Si tenure, si experience, si gender, at saka si civil status. Yung limang yon. Yung limang predictors na yon ang kasama sa model. Tinanggal natin yung race and number of dependents based on this one, backward integration using AIC. Okay, pause muna ako, class. Baka hindi na ako naiintindihan. All right. So, okay. I'm sorry, ha. Okay, so saan na tayo ngayon? Almost time na. Okay, so, isang oras. Okay, anyway, class, ang ginawa natin kanina, di ba? It was backward, no? Ito namang forward. So let me just share this with you. Asa? Ano mahabang message? Asa na ako? Sa forward. Okay, let me end in this class. Kasi di ba sabi natin dalawa, forward at saka backward. Yung stepwise na forward class, ito yung function niya. Forward, and then pwedeng AIC method. No? So if we run this, okay, similar to ng both kanina. So ano daw yung forward? Una ipasok si education, tapos si tenure, tapos si gender, tapos si civil status, tapos si experience. Notice class, itong limang to ipapasok. Ang basis niya, AIC. Okay? So kahit na experience, hindi siya statistically significant, okay pa rin yun according to forward. Kasi bumaba yung AIC nung pinasok natin si experience. Okay? So if we plot class, ito no, if you run this, medyo mahaba nga lang yun. No? Kasi, but anyway, ito na yung, I'll end here class. No? Okay. Yung pag ipapasama natin details, ito actually nangyayari class sa forward, no? Forward selection. So ito yung mga candidates natin. Initially class, yung model natin, hourly wage regressed on its average. Ito lang yung model natin. Associated with one means, ito class yung average niya. And then what will happen if ito yung choices natin, no? Pag ipapasok natin yung mga variables na to, ito ang mangyayari kay AIC, magiging 2777 siya. Pag race ang pinasok natin, 2871. So among these 7, ang pinakamagandang ipasok si education kasi mas pinakamaliit yung AIC. Kasi yung model natin class ba ito, underscore AIC. AIC method yan. So pinasok ko yun sa education. Ang nangyari class, pag pinasok sa education, magiging ang AIC natin, magiging ganito. So mas mababa ito kaysa Wala tayong predictor na gagamitin. Alright, so ito na yung model natin, di ba? Hourly wage, regression, education. So pag magpapasok pa tayo, class, tingnan nyo, sino dito yung best? Based on AIC, mas maganda ipasok natin si tenure. Kasi mas maliit yung AIC kung si education lang. So that's why, class, ito yung susunod na pinasok dito. Ayan, plus tenure. So ito na yung model natin. Okay? Hourly wage, regression, education, plus tenure. Ang AIC natin, 2685. Bumaba. Third step, class. Okay. Ano mangyayari kung itong mga ito papasok? Pinakamaganda si gender. Kasi from 2685, magiging 2643 yung AIC natin. So, inad si gender. Okay? So, nung inad si gender, ito na yung model natin, education plus senior plus gender. Alright? Then, yung mangyayari, class? So, ipapasok pa rin si civil status, ipinvest. Kasi, 2643 tayo. Pag ipasok natin, sino yung pinakamaganda ipasok? Si civil status kasi siya yung magbibigay sa atin ng lowest na AIC. Alright? So, plus civil status. So, ito na. 4 na, no? So, ilan na lang natitira, class? 3. And then, pag pinasok daw si experience, magiging ang AIC 2638. Ngayon kasi 2639. Alright, so ipapasok to, 2638. So, pinasok si experience. Now, take note, class, kanina, pag p-values ang gagamitin, hindi pa pwede si experience kasi hindi siya statistically significant. So, may difference yung AIC method at saka yung p-value method. Alright, so ito, step 5, 2638.6. Okay, pag pinasok mo pa si number of dependents, tataas ang si AIC. So, stop na tayo dito. So, ang model natin, education, tenure, gender, civil status, experience. So, that will be our model using forward regression. So, sinamarize niya yung mga pinasok, ito yung final model output. Yeah. Okay, so ang daming information, no? Alright, so let's stop there, class. We stop recording. Okay, I hope, paki-review yan, class, no? Paki-review yung, yung